Okay, hi everyone. Welcome back to the webinar for BIOH122. We were accidentally kicked out of the webinar, so I'm going to start all over again. Okay, so basically what I was trying to tell you is basically this webinar is about your first lab. So we are going to actually look at the first lab requirements, the guidelines, and what this lab is about. In today's webinar, I will be taking you through the theory part of the lab and basically how the experiment is conducted and what readings you will require and how you will calculate certain parameters like heart rate, for example, with the help of the RR interval. Okay, Avni, who is my colleague, will be doing another webinar tomorrow to take you through the data and how to use the data that you will be given. Okay, so if you have any questions regarding the lab, please feel free to post them in the chat room and I should be able to answer that. Okay, I'm just going to share my screen with all of you so that you can see the guidelines that we were talking about. So I'm going to share the screen and I'm hoping that you can see my screen. So I'm just going to log in. So when you go into the subject page, subject LMS, so you can actually see the assessment, under the assessment tab, you can see the lab report, the group lab report 1. Okay, so this lab is basically about the cardiac output and the effect of exercise and rest on the cardiac output. So I'm assuming that by now you have completed your theory. So you all know that cardiac output is basically the total amount of blood that is circulating in your heart per minute, right? So it is basically a combination of two factors. You have the stroke volume, which is the amount of blood that leaves the heart with each heartbeat, and multiply that by the number of times your heart beats in a minute. So cardiac output is basically heart rate multiplied by stroke volume. So assuming that our normal heart rate is around say 70 to 80 beats per minute and the stroke volume generally remains around 70 mils, so the cardiac output generally remains around 5 liters. Of course, it also depends upon the individual person, because obviously a large frame person will have a little bit more cardiac output. Children, they have a smaller body, so they have a little bit less cardiac output, but pretty much on that level. Okay, so what I was saying earlier before we were logged out of the webinar is basically to look at the cardiac activity, we use ECG. So traditionally we use a 12-lead ECG where 6 of these are the chest leads. So they put on the chest and they look at the different aspects of the heart from different angles of the heart. So you can actually look at all the parts of the heart, including the septum, the anterior septum, so interventricular septums, the chambers, and the anterior surface, the inferior surface, and the sides and everything. So for your lab, you are actually going to look at a limb lead, which is the lead 2, which is basically when you connect the 3 leads to the person's arms and one for the leg, for earthing. So from the right arm to the left arm, that is lead 1. From left arm to the left leg, right leg, that is the lead 2. And right arm to the right leg is lead 3. Okay, so you're going to look at the cardiac activity in lead 2. A typical ECG, when you look at the typical ECG, it comes up with lots of different waves and intervals. Okay, so this is what a typical ECG would look like in the ECG graph. Okay, so basically there are 3 main waves that you have to focus on. The first one is this P wave here, which is basically the atrial depolarization. So it is a time when the SA node, the conductive tissue of your heart, the pacemaker of your heart, receives the electrical signal, receives the nerve impulse, and it converts it into the electrical activity for the atria. So SA node, it being located in your right atrium is the first one to be depolarized, followed by the left atrium very shortly. So atrial activities, they pretty much overlap the ventricular activities. So you don't have a atrial diastole specifically, but you can actually see the atrial systole happening during the P wave. So it's basically the depolarization of both the atriums happening. Okay. Now, from the SA node, the impulses then go to your AV node, and from there down into the conductive tissue of the heart, including the bundle of His and the fibers, the Purkinje fibers. Okay, so time taken for the impulse to travel from the SA node to the bundle of His, that is your PR interval. So that is the time when your bundle of His starts depolarizing the ventricle. So from Q to R to S, so QRS complex, this is the QRS complex, right? So Q, R, and S. So these three waves that you see, they are basically a combination of a ventricular activity. So as the electrical impulse spreads through both the ventricles, they begin to contract. And that's why you see the sharp R wave, the positive R wave, and then with the not the depolarization, let's say repolarization. So with the ventricles emptying, they create the S wave, which is beginning of the ventricle starting to relax. Okay, so QRS interval or QRS duration, as it is mentioned here, is basically the ventricular activity. It is the time taken for the nerve impulse to spread across the ventricles and begin the ventricular contraction. Okay, then you have this positive T wave. This is a time of ventricular relaxation, so it's ventricular repolarization. So this is a time when ventricles are actually filling up with the blood during the atrial systole. So that's why I said that the atrial diastole and ventricular systole kind of overlap, so you can't see them separately. Okay, so when you look at an ECG, so these are the three main things we consider: P, QRS complex, and the T wave. Then there are two more intervals that you have to look at. First one is the ST segment. S to T segment, the time taken from S to T is the time taken from the ventricles to finish their contraction and begin their relaxation. So that is basically the time taken for the ventricles to repolarize. If there is any type of, say, blood clotting or happening in the cardiac arteries, you know, like infarction, for example, then this ST segment will be elevated, will be different. It means it takes longer for the ventricles to recharge and kind of start their activity again. Okay, so in this experiment, what you are going to do is basically, if you were in the classroom, you would have a volunteer who is hooked onto a transducer machine, and that transducer machine will record the cardiac activity of that person during rest and during exercise. So we first take the data at rest. What is the P R interval at rest? What is the QRS duration at rest? The ST interval, TP interval, all of that, and the RR interval, of course. So RR is basically, see, every R wave that you see on an ECG is kind of, it always coincides with the heart rate, you know. So by counting the RR interval, we can actually calculate the heart rate of the person. So the way to do that, I will show you the method to do that as well. Okay, because you will be doing that. So to calculate the heart rate of a person, we measure the RR interval. RR interval is the duration from first R wave to the next R wave, which will be somewhere here if I'm following the ECG. Okay, so that duration, these small squares, ideally speaking, we count the number of squares and then divide it by certain, like multiplied by 60 and things like that. But because we are looking at the millisecond interval time based, so what we are going to do is we are going to divide the inverse of the RR interval. So 1 divided by the RR interval in total, and then multiplied by 60. That will give you the heart rate. Okay, so you will be given the data for this lab by your lecturers. So once you are given the data, you can calculate the HRN, the heart rate using the RR interval that's been given to you. So here, this is one example that they have given you. Say, for example, the RR interval was 0.8 seconds, so, or in other words, 800 milliseconds. Okay, so if the RR interval was 0.8 seconds, then calculating the heart rate would be 1 divided by 0.8, which will be around 1.25. And this is time taken for one heartbeat. So you have to calculate it for a minute. So you then multiply it by 60. So that gives you the total beats per minute. Okay. So that's basically how we calculate the heart rate. Now, what exercise does to all this. Okay, so in this activity, in this lab, you are actually calculating two things. You are not only looking at these intervals, but you're also looking at the stroke volume. You're also looking at the pulse volume. Well, not actually the stroke volume, but the pulse volume, which means the amplitude of the pulse, how it changes. So whatever amount of blood leaves your heart, as it goes round through your blood vessels, it triggers a pulse, right? So that's what we are measuring. We are measuring the amplitude of the pulse. And then you're looking at how that amplitude changes with exercise. So you will be asked to use a data table like this one here. You can see the data table, which has a PR interval, the QRS duration, ST segment intervals, TP intervals, RR intervals, and for the heart rate. We start at the resting phase, then we start immediately after exercise. So we ask the person to do an exercise for about 2 minutes or 5 minutes, depending on their physical health. What we actually want is that their heart rate should go at least up to 110 or above for good results. You know, if the heart rate just manipulates a little bit, you might not see a lot of changes in the amplitude of the pulse or the RR intervals or the heart rate. Okay, so it has to go above 110. So that's why we ask them to do at least for 2 minutes or 3 to 4 minutes. Okay, so immediately after the exercise, we record these changes again, and that's when we look at the 0 seconds, so starting of the exercise, at the beginning of the exercise, then at 30 seconds, so halfway through, you can say, right, and at 60 seconds. Okay, so at end of 1 minute of the exercise. So this is done during the exercise when the person is actually doing the exercise. Okay, so this is another table that you will be provided with. So what you're looking at, the mean pulse amplitude here, right? So mean pulse amplitude is the amplitude of the blood flowing through the peripheral circulation. Okay, so you are going to look at this mean pulse amplitude at 10 seconds, 30 seconds, 60 seconds, and 120 seconds. So at 30 seconds, 1 minute, and 2 minutes. Okay, and you will observe the differences that are happening, and then there are some questions associated with these changes that you are seeing. Okay, so basically what is happening is that with the exercise, you know, the demand for the blood increases. So obviously the heart rate increases, and that causes the increase in the cardiac output. So you will see changes in the pulse amplitude where the amplitude may significantly increase. Now we are looking at the finger pulse. So there are chances that if somebody who is very fit, you know, physically very fit, and they have been regular athletes, so they have been practicing, say, yoga or any type of exercise regularly, then you might notice that the mean pulse amplitude actually decreases. And this is also quite normal to happen, but there is a reason for that. So one of the questions in your activity asks you about the pulse amplitude changes and why these changes happen. Okay, so but you will be provided the data, so you're not actually doing this activity in the class, so don't have to worry about that. But what I want to say is that generally speaking, the amplitude in the pulse will represent the blood flow to the peripheral system. Okay, so that's what the lab is about basically. So when you go down, say there are questions which are asking you to plot the graphs and also asking you to analyze them. Okay, so my colleague Avni will take you through these questions and how to plot the graphs and what is important. But just to bring it to your notice, what we are actually doing is when you're doing these graphs, make sure that you, first of all, the title of the graph is very clear. You have labeled all the intervals correctly, and you should be, the graph should be what you call, we should be able to compare what is happening at rest at 30 seconds and at 60 seconds after exercise. So the graph should be such that they are easily readable, clear, concise, and they have all the required information. If there are units that are applicable to the axis, then the units have to be mentioned correctly. Okay, all the axes, both the axis, the x and the y axis, have to be labeled correctly, and you should be able to compare the data. Okay, these graphs, you will have to upload them onto your wiki page. So under week 4, let's go back to our course material. And if you go back to week 4, okay. So these are your videos that you can watch that take you through how this data is collected. You will be provided with the data, but the video actually takes you through the actual experiment and how the data is collected as if you were in the class. Okay, so under the assessments, you have here a link to how to use the wiki. So please do watch this video on how to use the wiki, because for this assessment, you are going to work as a group and you are going to create your own group wiki. And you're going to post your answers onto that wiki. Okay, so I'm not going to open that video right now, but it basically takes you through the process of how to create or how to generate a wiki. Once you have created your wiki, you will then be able to post the messages. So like, for example, if you go here, this is the lab report 1 wiki. Now I have not created a wiki for myself, but I'm just showing you that this is what it would look like. So this is where you actually submit your wiki, and you can, let me go back. There is a, okay. So once you create your wiki, you will be able to post things onto your wiki. I don't think I can create a wiki unless I'm a part of a group. Okay, so but you can watch the video. Okay, that will show you how to do it. And when you're transposing your graphs to your wiki, you may have to save your graph as a JPEG, JPG, or a PDF format, and that will make it easier to upload onto the wiki. Okay, any other formats will not be supported by your wiki, so please make sure that you actually create a graph which can be converted to a JPG format. Okay, so that was about the wiki. So concepts that you require for your lab are basically things that you covered in week 2 and week 3. So you are going to look at the cardiac cycle, the ECG, the stroke volume, and how it basically changes. So anyone has any questions around the lab? Okay, so there are no questions around the lab. All right. Okay. So that was pretty much what I had to actually tell you. One more thing, let's go back to the ECG. I'm just going to open up one of your sessions over here. I believe it is this one. Just going to take you through the concept of ECG, right? Yep. So just quickly taking you through what happens when, what are we actually looking at, you know? So when the cardiac activity begins, right? So basically, this is what a typical ECG is like, right? So when the cardiac activity begins, the messages from your SA node, which is basically located in your right atrium, will travel down the conducting tissue into the ventricles and also to the left atrium. Okay, so the first positive deflection that you see is basically depolarization of both the ventria, and it's represented by the P wave. The next phase of the cardiac cycle is the atrial systole. So that's where the P wave is created during the atrial contraction. Now, if you remember from the cardiac cycle, in the early phase of your atrial systole, both the valves, the AV valves and the SL valves, are actually closed. Okay, towards the end of the systole, just about in the last 1 second of the atrial systole, the valves actually open up and the blood rushes into the ventricles. Okay, most of the blood flowing into the ventricles is a passive process from the valves filling up. Okay, in the last part of the atrial systole, the atria actually begin to contract and they push the last amount of the blood into the ventricles. Okay, once the blood is ventricles, the ventricular depolarization begins and the ventricles will begin to contract. So here you can see how the PQRS, so QRS complex has been forming. So you can see that the ventricles filling up are creating the negative Q wave for the repolarization wave. You can see it's a negative wave over here. And then as they fill up, the ventricles begin their contraction. So that is the positive depolarization, the strong R wave that you can see. So that's created during the ventricular systole. So R and S are basically responsible for the ventricular systole. S is created when the semilunar valves open and the blood rushes out of the ventricle. So that is in the last part of the ventricular systole. Okay, following that, when the ventricles are empty, that is the time of repolarization. So that is a T wave being created. You can see that the ventricles are now beginning to relax. Okay, so they have contracted. You can see the contraction, right? So this is the time when all the four valves are closed. So isovolumetric relaxation will begin now. So all the four valves are closed. The ventricles have pushed majority of its blood out. There is some ejection fraction always remains in the ventricles, and then the ventricles begin to relax. So that is the repolarization phase. So you can, in other words, say that the T wave is the time taken for the ventricles to fill up with the blood again. Okay, and then you have this is the completion of the T wave. This is when the AV valves open in the cardiac cycle and allow the blood to flow into the ventricles. Okay, so you will have to use this concept of cardiac cycle in answering some of the questions related to your lab. So I'm just going to take you through the questions that are asked over here. So just that I'm not missing out any important points for the assessment part. So if we go back here, let's go back to the assessment guidelines, group 1 lab reports, right? And let's go to the question. Okay, so the first question is basically taking you through the graph that you will create using the data that is provided to you. So once the data is provided to you, the data table, using the data that's given to you at a 30-second, 60-second, and at rest, using these values over here, you will create a graph. You can use Excel to create a graph, or you can use Microsoft Word to create a graph, whichever you are comfortable with. Actually, doesn't matter, as long as you can save it as a JPEG or a PDF file. Okay, so in the first space, first question, you are actually creating a graph to show the PR interval, the ST time interval, and the TP time interval, and RR interval. So 4 intervals at rest, 30 seconds and 60 seconds after exercise. Okay, as you create this graph, make sure that the title of the graph has to be appropriate. It should tell us what the graph is about. The axes have to be labeled correctly. The intervals have to be labeled correctly, and the correct units should be present around the intervals. Okay, and of course the time. Okay, so next question is also a graph. Here you are actually showing the graph of the mean pulse amplitude. So you're using the data for the mean pulse amplitude to create a graph over here, which shows the changes to the pulse amplitude at rest, after 10 seconds, after 30 seconds, and after 60 seconds. Same things apply to this graph as well. The title should be clear, axis should be labeled well, the graph should be appropriately presented, and all the units should be correct. Okay, And then there are a few questions around the understanding of these intervals. So what happens to the RR interval and heart rate after exercise? So just remember that whenever the heart rate increases, the RR interval will be shorter. So you will be able to see these in the data that is given to you, and you will have to explain why that happens. Okay. If there is a change, basically, right? So same thing for the TP interval. Again, you will have to go back to the cardiac cycle and the cardiac output and the phases of the cycle and how they are represented in the ECG. So session 4, was it? Yeah. So week 2, session 2, I think, or on the second session on the heart, that's where you will have all the things that you need there. Okay. And you have here a thing that where you might need to research a little bit, where you are actually talking about the RR interval and TP interval and how they are actually related. Now, cardiac arrhythmia is a condition where the rhythm of the heart is not regular. So see, regular rhythm is called a sinus rhythm. It's basically when your heart is regularly beating um, lub dub, lub dub, lub dub at a regular interval. So you have the systolic and the diastolic sounds coming in at a regular interval, and it's pretty evenly spread out. Okay. Arrhythmias can arise for a number of different reasons. There can be arrhythmias when the heartbeats are irregular. There can be arrhythmias when the ventricles are working at a different signal than the atriums. There can be arrhythmias when the heart rate is too quick, like a tachycardia, or even when it's very slow, like a bradycardia. So you will have to research a little bit over here about the cardiac arrhythmias, and then you will have to relate it back to the changes in the TP interval and the RR interval that you are given from the data. Okay. So that's basically the questions. And then again, the same thing is happening for the pulse amplitude. Whatever changes you see in the pulse amplitude in the data given to you, that is what you are explaining. Okay. So that's pretty much it from me for this webinar. Okay, I will be conducting regular webinars for this subject from now on. So my next webinar is on Wednesday, and Wednesday we are going to look at the lymphatic system. Now these webinars are for like a revision webinar, so I will not be able to take you through all the concepts, but I will try to cover the major concepts that are in each session, which are kind of difficult to understand. Okay, so you already have access to the screencast for the subject. So can I please request everybody to watch the screencasts and kind of prepare the questions that you might want to ask me during the webinar. Okay, hoping to see you all at the webinar on Wednesday. So that's all from me for today.